Hello, everyone. Welcome to the Fluid Operations Podcast, Episode 5. We are back with you today. I'm Miller Truby from Turing. With me, as always, is my co-host Kirk Wessel, also from Turing. And today, joining us, we have Joerg Hertwich. Did I say that correctly, Joerg?
Yes, very good.
Okay,
You're
good.
one of the few ones where I don't get out as Jeorg or as so.
Joerg Hertwich from New Zealand, and tell us, what's the name of your company? You're an independent consultant, right, Joerg?
Yes, yeah. I've been self-employed for almost all my life. Yeah.
H
The name is H2O, but it's actually my surname Hertwich. So I'm just I'm not advertising myself big time. It's more like how is it in the industry? People know you and you get handed down a long chain. Yeah,
Absolutely. Yeah, the name precedes the work.
exactly. Usually, yeah.
Very good.
Yep.
So yeah, we're
Yep.
excited about today. I'm talking to someone. I think everything that we've done so far on this podcast has been focused on North America and the North American market. Joerg, you bring quite a bit of international experience with a different type of plants than the operators we've talked to so far, and a different kind of experience because I think you come from the design, operations, startup, and commissioning, troubleshooting side of things, but then with real world operational experience. So we're very excited to have you on today to kind of talk about tech in this industry and how it's applied and what the operators and the everyday people in the field face when trying to solve problems and do their day-to-day jobs, and sort of what we can all do better as an industry, and especially with the tech side of the industry, which is, of course, what Kirk and I are focused on. So very excited to have you here. Thank you for making the time to join us, 17 hours in the future for us, I believe. Yeah. So why don't you, before we start peppering you with questions, do you want to just give a quick introduction to yourself and sort of what you've done in the industry and where you're coming from?
Sure, no problem. So as Miller already introduced me, I'm Joerg Hertwich. I'm originally from Germany. So I started my work very early in the water treatment during university, not really knowing what to do with technical chemistry. I landed in a research and technical development center during my practical term, and it was about membranes. Film tech Dow at that time, very early, mid 80s. I got really excited because I didn't want to learn end in the production of organic chemistry or somewhere in the big companies or in Europe. So this triggered something in me. So I also did my final thesis in this. Funny enough, on an algorithm for nanofiltration. So not even thinking about anything about AI, we tried to find just trying to make application about how different ions pass through nanofiltration membranes for British water system. Simple, base MS basics at that time, but exciting for a young chap in Germany who only had big process computers in the university and not IBM like Dow and Filmbeck had there. And for me, it was like a big eye opener. Also sitting in the meetings with an international company right out of uni, which was really structured, suddenly these completely different fields. So I got really excited, but I still had to do my civil service in Germany. So I ended up in a lab doing environmental things, which was also great at this time in Germany. So I ended up in research and in a research project about mobility of mercury in soil and air. And out of that one, I actually got self-employed, a little engineering consulting company, monitoring in air, monitoring water, operating some little water treatment plants, making connections. For a couple of years, I worked for a wonderful company where I learned a lot in Germany for beverage treatment and mineral water. So I learned heaps there. What you don't learn in uni, as you know from people who are not actually chemists, you learn about water chemistry from the field, how microbes are involved. So I learned heaps. But by the late 1990s, we had 3 little children, and kind of came to the point on a ladder in typical German, it's very successful. No more time for the family, always in the car. We are not flying like you in America. You question yourself, so is this what you want to do? And we looked at each other, my wife and me, and we said, well, look, we need more time. We do something different, and we moved to New Zealand with a family of 3 little kids, and we ended up in this spot, what you see behind me. Lovely. We built a log house ourselves without any help. Reasonable professional, not like with an axe, but with some machinery. So we still live in this house. The kids are all back in Europe studying, and most of them work. And so we are at this point of time where we're kind of free again. And this is why I can join this podcast, have a bit of extra time. But when I came here to New Zealand, I fell back to the water treatment industry from membrane solutions, because New Zealand doesn't need much water, but we've got Australia very close by and other countries. And through these connections, it took a few years, like almost 10 years, but I found a foothold again, and I ended up consulting for consulting offices, usually like not directly to big clients, but usually as the specialist being called in, or to fill gaps where shortages, and doing troubleshooting, doing audits, doing commissioning, especially in Australia, but also Pakistan, Nauru, little islands. I ended up in Chile for several projects, usually short term, but at the most interesting point of these plants, either when operations failed or at the commissioning point when water started to flow and people struggled to bring people together. So really a field of learning where you really get exposed to also the traits which you usually not learn in school. You're suddenly involved with management, with construction guys, everybody, automation guys. So all around you coming from the chemistry, water chemistry, you suddenly have to deal with all these people, and you learn. And you have to teach them, you have to tell them and learn to explain what you actually want from them. And this is a wonderful process. I just love it. And this is actually one of my reasons why I like to join these podcasts, to tell young guys, young engineers, the most exciting part is not getting a project engineer and spend somewhere between a project manager and the client, getting ground down every day on trying to deliver a project, but to get out in the field and get involved and get commissioned. And this is where you start really learning after uni. And this is fantastic. You make connections all over the world. You get taste food, incredible stuff, and you meet incredible people from the operator all the way to the top management, because people are excited and sometimes under a lot of pressure. It's a high pressure environment often. So also from a financial point of view, but it's fantastic to learn, because you were exposed to a lot of things, and I really enjoy that. I'm starting to roll back a bit, less traveling, so doing a lot from home, which brings us back to like remote monitoring of plants and data acquisition, and also where I'm struggling, or where for a long time I'm struggling. If you get per fax or per a PDF, you get handwritten notes.
Yep.
It's pretty hard, spending engineering hours to type in these data, or nowadays, okay, at least you get Excel sheets sometimes, but you usually don't have quality access, real-time data. We hooked something up ourselves during COVID. It's possible on a small scale, but usually there are big hurdles from technical side, from administrative side, from safety side. But it's wonderful, having these access. I could do a lot of my work a lot faster, because the data, pre-prepared data, would allow a lot more of the troubleshooting quicker. You come from this field. I watched the first episode. I watched all 3 episodes, but the first episode, I really often had to smile, because I see all these points what Miller said from the commissioning side, and what Kirk said about that our industry is often wasteful, and that we have to go back to simplicity. We're just doing a bit of show off with our SCADA DCS systems, but we are not the smartest so far to get back to basics and do the right thing first. But we can come to the point later. I'm sure you have got some questions. It was just a quick overview of what I'm doing and where I'm coming from.
No, that's perfect, and we appreciate the intro. And yeah, I just want to point out that I think all 3 of us on this call have followed a similar trajectory, albeit ending up in kind of different situations. But all 3 of us started, outside of the hard water. None of us, I don't think, started as straight up water people, and kind of ended up going through more of the practical side of the industry, and seeing it that way. And yeah, I think it does give myself, I'll speak for myself and won't put words in everybody else's mouth, but I think it does give me a different point of view about what works and what doesn't work. And, the difference between good engineering on paper versus good engineering actually out in the field trying to make water at some of these sites. And, depending on where you are, things can get very ugly, very difficult, very fast. And I know, Kirk, I know you've talked about that in the past of your experience coming up, obviously not through the membrane side of things like Jeorg and I myself, but same thing, I think, coming in, learning the practical effects and, figuring out how to make a career out of that, and also how to make a difference for everybody else who is actually trying to run these things day to day.
Yeah, absolutely. Absolutely. I mean, there's so much complication. Obviously, most everyone knows I come from more of a wastewater background, and the upsets in biology and how catastrophic that can be when, stuff happens. People are illegally dumping and all those different things that happen and upset plants. Well, those plants don't just change in a second. You don't just turn the water on and turn it off. You kill that biology, and they have to manage that and fix it before they obviously let it go to the river. So there's, those are huge challenges everywhere. And obviously, like we've talked about, we need a lot of data to understand that information and how that's coming. So it starts from as we collect it all the way through. So it is very interesting. Jeorg, you have a unique background being obviously international, started a long time ago, obviously started very much paper driven, starting to see this step going to digital. But my question resonates actually before that. Obviously, as we treat water and the commissioning of plants, is there a difference in every country? Do they treat the water the same? Is it a little bit different everywhere? How's that work, or how's that look? Because I don't know the answer to that.
So from a basic understanding, it's the same everywhere. I'm talking about membrane technologies. I'm sure, some people rely more on very traditional methods like flocculation and not, are not so flexible like riverbed bank filtration, things like that. These come slower in some countries, but I think this is normal. It's just the process they go through, and also the challenges like you in wastewater, what these countries face. In a country like New Zealand, without really old industrial sites, we don't have the challenges like in US or in America, where you have many sites where the groundwater is contaminated right from 200 years ago, or even worse. We have a few sites. So seawater or high salinity water, the treatment processes is quite similar, and actually also the knowledge base from operators. You would be surprised how great the knowledge base is, all from South America to India. A lot of this comes because operators have also moved. If you think about the Middle East, I work a lot in the Middle East on these mega plants nowadays, more from a management side, because I'm just drifting in this direction, and how exhausting commissioning can be if you get gray hair and you have the stress, it can kill you. So these 16 hours a day things where you're under full pressure, you cannot do that after a while, or you could, but it costs. So right. I'm more on the management side. It's also stressful, but it's a different stress. Some more where you can give more and you can do more of the mentoring. So, but all in all, to come back to your question, the seawater side, I think the challenges are the same. So the reaction are the same. And what I just want to finish with the people, like in the Middle East, you have a lot of people from Pakistan, India, and Asia, from the Philippines, and they've been there for 25 years or longer, and they bring all these knowledge back to their countries. And you find them also in different countries. So these feedback, and it's probably with the US a bit like with South America. And also South America now in the Middle East. I know a few people in the Philippines, in the Spanish-speaking countries, and they bring these information back. So they've created a really good pool of knowledgeable people. But from a challenging point, seawater is like wastewater. You would be surprised how different seawater is, each location. It's, again, microbiology, and it's not the same. We have algae blooms. We have currents in the water. Temperature makes a huge difference to membranes anyway, but also to plankton growth, to biofouling on the membrane. So really each location, if you think 20 kilometers down a coast, could be more challenging if it's close to a river inlet. And so each plant, even in seawater, where you think everything has like 40 grams of sodium chloride in it, the challenges are different. And so it's nice. It's a fantastic thing when you discover that one, how different that is.
Yep.
So a lot of learning, lot to learn, even in these plants where I think technology is the same, basic pre-treatment, basic membranes, basic design. The challenges are always open for people to solve. So good data is essential.
Yeah. And I think that's right on with the data side of it as we continue to develop, getting the data to be able to run these plants, because like you said, they're set up similar, but the data is going to be different. So you got to run them a little bit different. You may have to clean them a little lot more frequently, or do your, whatever you need to do. That's interesting. Thank you.
Yeah. Well,
and this. Oh, sorry.
Go ahead.
For me, it's just to put that also on a commercial perspective. These mega plants are designed very, very cost efficient. They are down to a bit over 30 cents a cubic meter production because they are so big. They're like the last one was 680,000 cubic meters a day. So really big plants. So every cleaning costs availability of a train. Every stop for 2-3 hours costs. Every biocide stop for flushing costs. Or even losses in production, they're very, very expensive. So it's getting even more important that these plants just start and stop. You cannot afford it in your budgeting, and also these big plants are often now BOOT or others where private investors invest the money. So it's, from a commercial point of view, it's getting even more interest to keep these plants running, always running, and see any problems, see them coming, understand them and see them coming early, because the problems are there. We cannot remove the problems, and especially special occasions like a storm or whatever, but or the microbiology, you will not be able to catch all, but you should see them coming by learning through pattern recognition. And this is the key thing, that you have a database and you use it, that you get this database of 2-3 years and you use it to predict, that doesn't have the prediction. I'm not sure if we can catch all the prediction by automation, but that you have got these database and got these collection and sorting out the errors, that you as a specialist can see trends and can also advise the design team later on, which is, you probably know from wastewater and you from membrane technology. The feedback from commissioning and from operation to design is very, very slow in our industry.
Mm-hmm.
Yeah, because old systems work and you don't take risks.
Yep.
Because it's a long year investment. So this base of good data would allow the facts. You can put the facts on the table, say, look, 3-4 years, we did this. Now we've got very clear data written down or in perfect graphs. We need to change. This was a design fault, or we can do better on these ones. So it's the feedback will improve also the designs.
And it's a great point that you've brought up, Joerg, and it harkens back to the beginnings of, even before we were touring. The company that I joined was Synata, which was Mike Dixon's startup company. And the whole intent of Synata was to approach these mega plants and basically sell them on the idea that, hey, if we can even save you just a few percent energy, it doesn't sound like much when you look at it as a percentage, but when you convert that into kilowatt hours and then you convert that into dollars or reals or whatever it may be, it's actually a lot of money. And because, that only works because you're building these giant mega plants now. If it's a 5,000 cubic meter per day plant and you go and you say, we can save you 5% of your energy cost, they might say, that's a few $100s a month or a few $1,000s a month. That's not a big enough deal for us to spend the time and the effort.
Yeah.
When it's a 300,000 cubic meter per day plant and you go and you say, we can save you 5%, their ears perk up because that is a 7-figure savings potentially. And you know, it doesn't sound impressive when you say it as a percentage, but because of the scale of these systems that are being built now, and especially on the seawater desalination side in certain parts of the world, you know, every little bit makes a significant difference, and you really can't do that with human based optimization, you know, like you would the old-fashioned way, the way that I've done it, and I'm sure you've done it. That doesn't work as well when you start getting to scale that big, and so many plants that big around the world. So it's funny, everything you're saying, it lines up with the beginnings of the company that I started with, that has now turned into Turing.
No, I was in contact with Mike too, through Osmoflow and these connections, you know, going way back for a smaller plant. But we both, we knew it, and we both saw that immediately, which brings me to the next point. Physical parameters, some of the physical parameters are caught well, which makes AI in water treatment really suitable for networks in the moment. You've got pressures, you've got temperatures. You know, you might get from your pumps the curves, the electrical consumption, and these things. So it's like a network of a few parameters, like 5-6 parameters, and this works. In our industry, where this was a rental plant or these big plants, this brings me back to Kirk's point in the first episode, you know, that we are not very smart in planning these plants, and we have to go back to limits. Our analyzers, you know, and our recording of data, it's like the senses the AI needs. AI is a brain. The pattern recognition needs valuable data, and this is where we really have to start and have to improve our industry. We have to find that the sensoric in our plants, that we have different level of sensorics. And I don't think too many people talk about that. We have to come down for your system and other systems where you try to do pattern recognition to a few very, very robust sensors, like in the car industry. I have a good friend, Lee Watson. He comes out of the car industry. Now he will love that. The car industry are with cheap sensors very, very early. You know, the whole car is full of sensors which drive through mud, through ice. But we in our industry, we have quite a lot of sensors which need recalibration, right? Which, you know, which don't really suit often. Like, think about conductivity in seawater. Most plants have conductive electrodes. They're cheaper. They're pain in the neck. Sorry to say that, but it's like if you want to do a energy efficient system and you have 5-6 electrodes, if you don't calibrate them all the time, you will never get the right idea. So we, together with my friend Lee, we thought about using one sensor only and try to catch the whole thing by different streams of water, you know. But on the other hand, they are inductive systems, more expensive, very robust. Inductive sensors would be the right thing. You would never have to clean them, and you would make a lot of savings. So don't save during the design phase. If you want to do good data, you need very good sensoric. And this, you know, this is a key where we have to work on. My youngest son, when he asked me, I like chemistry, physics, and all math, you know, what do you think, you know? I said, look, how the world is going, I would look at sensoric. Don't go for artificial intelligence. Go for something with sensoric, because this will be the key. AI cannot work if the data is not okay.
Absolutely.
You know, and this is where the young guys, very exciting field, INC, and really improve all these plants and put a level in the we have 3 levels actually. I'm not sure, maybe you find more, but I thought a bit about water treatment plants. We actually have 3 levels of sensoric. One is our basic level where we record data for control. The second level, one level is commercial, which has to be highly accurate flow meters and systems for the commercial recording of volume, of quality. And we have one other thing for analytical level where we measure quality of the water in the plant. You know, and some of these analyzers are hard to calibrate or need often calibration. But we have not so far in our industry really make a big difference. Often the controls use a mix of these data, but we shouldn't. We should have a very robust system of analyzers only for your systems, you know, for data collection. best quality sensoric, least calibration. They could be even just leading parameters. They don't have to be the exact measurement. Like you don't need like a chlorine value or ORP for which need to be calibrated. It could be some other parameter that represents this, but which is robuster, just like a for trending. This is what I think our industry needs to do, this step, or replace it, and then go back that we have a good database.
And it's I think you bring up a good point that a lot of people haven't considered unless they've been an engineer trying to work on one of these systems, and that is you can sensorize and get telemetry from a lot of the different parts of one of these treatment plants, but it's almost impossible to sensorize every single thing that you want to see. It's cost prohibitive, especially if you're investing in nice sensors like you were talking about. But the thing is, if you spend the money on nice sensors and nice equipment and you buy things that are well engineered, well maintained, made from the right materials, and then you have the right intelligence in place, you can build soft sensors for the rest of it that will do a good job. Yes. But if the data that you're feeding to those soft sensors from the real telemetry is not reliable, those soft sensors also aren't reliable. And that, it I think catches people out. And sometimes, we run into this all the time with data quality, where there's an assumption that, by some magic, machine learning and artificial intelligence can take a bad data stream and figure out good data from it. And that's not the way it works. Nothing works that way.
Yeah. Exactly. It's like almost like what we all know when you get a lot of data from a third-party analysis or a site lab. You have to understand where it's coming from. How qualified is your chemist? How qualified is the lab? Is it accredited? Can I trust it? Did I run some samples? I know the value through them. And it's a bit like with the AI. If you're not sure what you're getting, you're wasting your time. So this is why my idea in the moment is really for these. Go back and think about the sensoric in our, which is Kirk's thing about simplification. I think we moved away from originally, when I started in this German company called Kriba, we did little breweries and little deferrilization, filtration, and they were the old water masters. And he had 2 apprentices. Right? This was it, still in the 80s. He knew, he did his own analysis. He knew the process. So he didn't need a lot of analyzers, and whatever he did, he understood. But then over the years, we got automation in. First, we got SBS systems or Siemens, whatever, our automation system. And then we got the nice SCADA and DCS systems displaying a lot of funny things on the screens. And the more flickering lights and the more data you had, the better it looks. Great sales point. But we're also starting to overwhelm operators and also detach them from the field. You got now DCS operators who don't go out in the field, and this is a big risk. So if you cannot rely in your data you're getting and you see it, so again, we have to go back to basics, and you need good people there, no question. But they have to trust what they are seeing, and if not, they lose confidence, and you're in trouble with your whole operation.
I think that's a big part of what we're looking at is, when we look at our screens and the SCADA part of our system and things of that nature, being able to walk around with that right in front of you. Now you can get out of that. You don't have to sit there all the time. You can walk the plant. You can see everything going on. And if something alerts you, you can look at it and see what's going on, not sitting in the SCADA room. That's a huge value to where now you can be out as an expert training some of the younger staff that's there and things of that nature. So I see that as a huge benefit with the digitalization of the processes that we're looking at, plus capturing all the knowledge. That is capturing 100%. All this knowledge. I talk about that all the time, Jeorg, is if we can capture the knowledge of how someone maintained this, fixed this, how did they operate the plant when they got overloaded with, 1 million gallons they weren't expecting, how did they run that plant? Well, this guy's been here 2 weeks. How's he going to know that? No one's there to tell him how to do it. He can type into the chat and say, hey, how do I do this? And it pulls it up or in the search history, and he can find, hey, John did that in 2025 and it's 2030. He did it this way and it worked. Okay, well, I can do that now. So just giving them better intelligence, quicker answers is going to help us all. So it's a fun area to be in right now.
No, definitely. And also for predictive maintenance and maintenance part of it, I'm not so much involved with that one. If I do troubleshooting, yes, and we involve in our commissioning process the O&M teams more and more on these split plants. We bring them in early, half a year early, so the handover is a lot better. But you see, they have a different viewpoint, and it's very important, and this is where AI, often these operations, they can be overwhelming. If something goes wrong, it can go very wrong. And then if you have a really good system where you can have your maintenance system automized and red flags going up, and you don't have to look every parameter all the way, or you can look at some equipment where you learn, again, this pump again, or this analyzer, this is doing too much trouble. Let's see, can we replace it? On the big plants, it's a big saving long term,
And people don't object to that as much either, because it feels like, I think a lot of people are still stuck on the idea that when you do AI for optimization of a process where it's making recommendations about how to run the plant, that feels like it's taking some agency away from the human operators, which is something that everyone is still uncomfortable with, and us included. On the other hand, though, when you start saying that you can use the AI to basically just keep an eye on everything and flag when something is going wrong with a piece of equipment early, no one really wants to object to that, because the reality is the operators at these plants almost never have the ability to watch the plant that closely and watch every single piece of equipment, every single pump, every single whatever it may be. They don't have the bandwidth or the wherewithal to do that, and it doesn't feel like it's intrusive in the sense that it's not making decisions. It's just flagging, hey, this might need attention, or hey, go over there, that thing is on fire. You might not see it as early, and that seems like a great starting point for this stuff.
Exactly, and it's usually too late. If it's really digital, it's as it is. It's a digital signal, a warning. First the warning, then the alarm, and usually it's too late.
Yep.
And if someone can take that off your shoulders, that there's a trend, and he's telling you, look, we are not at warning level, but this is not going right. Something is wrong. In the last few weeks, it didn't do this. Now it's doing this. Please, please help me. This is what we got this background looking at the trends, because this is what we are doing. You both know it, First thing you do a walk down in the plant, and then you look at trends. Key parameters. How is it trending? How was it trending a year ago at the same conditions? And out of that, you usually, by looking at pattern recognition, you try to find the root cause. And if this can be flagged earlier, 100%, the operation have a tool that they don't run the plant into the ground and get a lot of pressure from the management, but can actually even come back to us as professionals early and say, look, I have this funny trend. I know how to deal with it, but something is not right in the design, maybe, or in our chemistry or in our dosing. Can you help me? Can you educate me in this part? And we have to dig in deeper, because usually you don't have the answer. As you don't have the answer right away. It's just that you have the time and maybe the resources, also in a network like us, to find the root cause.
So that's a good segue into a question that I wanted to ask you, Joerg, with your background. And I have my own opinions on this, because I think you and I have done some of the same type of troubleshooting trips and calls out at some of these big mega desal plants. But from your experience, I'm going to put you in a hypothetical situation here. Let's say you got a call from a operations and maintenance company that's running a big mega desal plant. They have a problem at the site. We won't specify what the problem is, but let's just say they have an issue with something related to the RO trains at a big seawater desalination system. And they say, Joerg, we need someone with experience to come to the site and tell us what's going on, because we can't figure it out. Can you walk us through what that process would be like for you when you arrive on the site? What do you look at? Who do you talk to? How do you gather that information? And sort of what is the state of the art now? And then maybe we can talk about what some of the ways that the tech tools that are coming in might change that in the future.
Yeah. So from a general approach, and this is actually the wasteful part, and this is why I'm already moving forward by doing remote work. You get a call urgently, urgent flight, expensive, last minute rush, you fly in, you're exhausted, and a big pressure. We have to fix this one. We have to bring this water to our client, or the pressure is mounting from our feet. Something is wrong. So it's actually usually quite high wire things, happening, and people are very excited. So people are also not really quiet under these. If it's really like an emergency and people are under stress, fear of losing their job, fear of making a mistake. So it's a bit of psychology too, First you have to calm down the people a little bit sometimes, and usually talk to the operator themselves often, bypass some management levels. Sure, you have to talk to the manager too, but in the end, you will only get to the root cause if you know what the operator did, and how. So it's about doing a walk through the plant. That is the first thing, really question with the people who recorded these things, go through on all levels, ask them, what do you think, where does the problem come from? So you have to understand, because often the problem itself is not understood. It's only the result that is usually highlighted. Like we cannot produce, we have our membranes have fouled, so people have a lot of opinions what it was, it was the fault of the pre-treatment, it was the fault of someone else sometimes. But you have to really talk to a lot of people and gather all the opinion, because there is very valuable information in there. A bit of detective work, walk the plant, look at the designs, of course, and then sit down in the DCF. It's a big plant. They all have DCS system or SCADA system. Look at the trends, bit like pattern recognition. This is again what the AI can probably take off me in some ways. Look at the pattern and also look whether the data actually makes sense. And this is often where we come back to sensoric. One thing is like what I said with contiguity. Another thing is ORP. Typically, often like no earthing or something on the ORP sensor is drifting, and things have been done, not been done wrong, but the maintenance of some sensorics was not right or not understood in the correct way, or even bypassed. Sometimes out of fear of losing your job, some analytics just put in simulation mode. Yep. You face this,
Yep.
It's fear driven usually. It's not by purpose or to be angry. It's usually just if you your job depend on your family, you get these situations here. So all in all, you do a bit of detective work, find patterns, and then try to get down to the root cause of the fault. And try. Yeah.
Would you generally be able to see the data and the information of the design before arriving at the site, or is that something that you're finding out only after you've traveled halfway across the world and arrived to the site?
It really depends. It depends on the site. If people are open and people know me, they will share data. If they don't know me, I usually don't get any data shared. And this is any big operation is very reluctant to share data. And I understand why, a lot of companies don't even use public cloud systems or allow even inside countries. Some countries don't even allow the data to be stored outside of their country. So this is a bit of a hurdle. I think it will change, and you can filter it. I don't need access to this data directly. I can have it through a diode, whatever. But there's a lot of a bit of a hurdle of understanding and fear-driven of cybersecurity too, but also normal security. You don't share all your data with someone you don't know. But if I know the people, I said, please give me this trend, send me the latest water analysis, send me some Excel sheets, please do this testing. If we have a bit of time, if it's not really emergency, I get this data, but I have to specify, I want. Sometimes I can do some testing, please do a profiling on this train, on the other train, give me some historic data. I go through and I probably can help them to stabilize the system. And then if I know the plant already, I might not need to go there. And this is the point where I'm at now, which is fantastic for me, getting a bit wary of traveling so far, that the plants and the people you trust, I can really help from a distance, and we can advise on different, if the openness is there and the trust is there, you can do it. But if it's a new job, I usually have to go there and establish this relationship, and afterwards follow up. It's a lot easier.
Yeah, absolutely.
But access would be fantastic. Direct access would be a dream for me, because then I could really stop all the wasteful time, which costs money too for the client.
Exactly, and that's really what I was trying to drive at with that. Is there's a significant amount of work and time put in just to start the investigation before you've even arrived at site on some of these jobs where you're asked to come up with a solution either by traveling to the site or by looking at data remotely. Just getting the data in a lot of cases can take days, weeks, sometimes months. And it's something that's often, in a role like yours where it might be out of your control. You can tell them what you need, but then somebody at the site has to go and pull all of those trends, all of those CSV files, put them in order, vet them and make sure that they're what you actually asked for, send them across to you. Then you have to sort them out, look through them, do your analysis, and then make a decision about whether to go or no go, or whether you have an answer or not. We know from experience that can be quite a long and sometimes arduous process, especially if what you ask for the first time doesn't actually end up coming through. Then you're doing detective work to solve a data problem so that you can solve the data problem and then fix the actual problem that they originally asked you to solve. I've been in that position.
100%. You get a CSV file you just mentioned, in resolution of a few seconds, and you try to solve that in a normal computer, and it's not very practical,
Yes,
it is true, we all know that, and we need to get that. But it's human nature, and trust is one part we have to establish. I will not get around looking at the PNIDs or looking at screenshots of the SCADA to get really an idea about the plant, or looking at the control philosophy if it's getting a bit more complicated, and talk to the operators to really understand whether it's driven by a obvious problem in the controls, which can happen, even by changes. So this will not be taken away, I think, on a short term, because these fouling will happen in our plants. But a good set of data will make that a lot easier.
Yes.
Life would be ideal. Live data would be fantastic. Yeah.
Right. You could just log in and see what the plant's doing live.
Exactly. And companies have that, and that brings me to the next point. Several companies, especially water treatment companies who sell plants, Gradient will be the same, maybe as like removed from touring, but also the big suppliers of these big plants, they offer their own systems. But the problem is they're kind of you will lock yourself in usually with a company on very expensive systems, and also from a data exchangeability. And I see actually quite a bit of reluctance. Some big corporates develop their own systems, but it's also a task extremely challenging. If I look at Synoda and touring, this goes back quite a while now with Synoda, and before you come to the point that you can have a fully reliant, trained platform, you need very deep pockets, to get these and make it applicable to different plants too. So ideally, you should really have something where you can offer a client and say, look, we have the data, use our system, we are the best. But if you choose to do some other, here's the data, it's your data, it's on the cloud, you can have it on your cloud, be confident. This is what makes the difference in this industry. We are not the best, nobody is the best, but if you can trust and say, look, we try to do the best, and we create a platform, only then the system will grow. If everybody tries to do its own little thing, we will end up with pocket solutions, and I don't think it will actually grow and drive to excellence.
Of course.
No, I agree with that. I do think that, we're focused, and I think that's why we separated off from our former parent company and became Touring by itself for that exact reason. We are a software company. That's what we're focused on in the water industry, to focus on that. So we're constantly developing new things all the time. You bring a challenge to us, we're going to figure out how to address that challenge with our platform. So I think that's a huge benefit, and as things continue to get developed, if you're already on the platform, you're going to have access to that too. So, we're learning every day, just like everyone else, and we're learning from other things, other challenges. And as we address those challenges, maybe that's something you can use, maybe it's not something you use. Well, you can either click on the button or not. It's your choice at that point. It's not quite that simple, but I think we kind of get the idea there. So, I totally agree with that. I love that idea. It'd be great if we can continue to foster that, because we do have so many little, like you said, pockets everywhere. It makes it really challenging. And siloed data is a time killer for so many utilities. I was talking to a utility just the other day, and they said they were working with this company, and they didn't even know. There's like 5 of them in the room, and none of them even knew that this sensor even existed in their system.
Oh, yes.
It was buried in a bush, and no one even knew it was there.
Yeah, and this is when you get detached actually from your equipment, and you should never allow that. It should be another tool, another screwdriver, another thing in your pocket, which you should use daily. But you should know you need to know your plan. And this is where I'm coming back to what I said about the young guys. It can also open the doors for the next generation. If you have these tools, suddenly a lot of the INC and commissioning engineers come from the electrical side. I'm not. I come from the process side because I kind of jumped in later. But for these guys, if they would have access to all these data of one plant or maybe of several systems, the learning, and they could dive into things. They can look at trends themselves, and they can ask questions. So it can bring them from this isolated point where they just do pre-commissionings and never really understand what they're doing, do just the electrical setup, the sensors. I can do that to the process side of things. So they could grow and get into great commissioning guys or great advisors for the operation teams of different systems. So I think it's also really, and it's interesting. Like if I would be a young engineer, I don't want to sit as a project engineer and trying to get everything ready to sell the next plant. I see that quite often. It's if you're out in the field and could work with these data, you can grow and you can learn it. It's exciting. So,
and it's a point that we've heard a few times recently, that the operator of the future does not really fit the profile of the operator of today, because those folks coming into the industry in the next 10 years. As the sort of tech offerings that are out there become the standard, and as companies start building these plants and these systems with these types of tools in mind, those younger folks who are coming in with that as the standard, they're going to be operators who are effectively IT people at the same time. They really need to understand not just the water process, but it would be heavily beneficial for them to understand the data architecture. They don't have to necessarily be computer science majors or developers or anything like that, but having a rudimentary understanding of how these systems work and how the data is architected and stored. If you're looking for a way in to this industry as an operator that will shoot up in value probably very quickly, that would be it. Take some computer science classes, take some IT classes, take some database, learn SQL, something like that, because that will make you much more valuable, I think, as an operator, because this stuff is going to be at every plant at some point. And the people who understand it are going to be the people who can use it and further their careers, I think.
Yes, but it's also important. You raised a good point, but it's the young guys, they should not fear that, because not everybody comes from a university degree or a higher level education. Oh, no. But it's exactly the opposite. It's often the best guys are the ones that had 10-year experience, started as a plumber, started as an electrician, fixing all these things, knowing the real problems of the plant, and not coming from data science background, but they see it and suddenly they have a new tool. They're great with tools, they care for their tools too, So these guys, if you give them these new tool, and they are kind of not operator who just want to sit in his thing and hope nothing goes wrong. But if you're a certain age, you usually don't do that. You want to develop, and you're excited. If I come to sites, you always have one or two of the young guys after you broke the ice a little bit. They are hungry of knowledge, As if you integrate them, if you take them along and say, look, these trains, I don't know what it is, but what could it be? Could it be the sensor? Did you have problems? And they get really excited, And this is the thing, you can be a plumber and you get a bit of stuck in your job and get a bit boring, and suddenly you have a tool and you can go back to your engineer and say, look at these trends, I shouldn't, but this doesn't feel right, and I know this sensor was not right, or these pumps, we had problems with noises. Maybe you should use different supplier, whatever, and they will learn. And they could do this next step, then, as you said, going in the IT direction, understand where the data is coming from, how important their sensoric actually is, or their maintenance of some equipment, how that feeds in and how they can use it, and support actually their management. And suddenly they get very, very valuable, as you said, but not just by pre-training in the uni or by educating yourself up to here and then go out in the field for the first time and don't really know what's happening in the field. So I think for people from a plumber electrical level, fantastic opportunities.
Yeah, I think we agree. I think that's that practical experience is invaluable, especially if you have an open mind and you're willing to learn.
Yes.
Okay.
What's amazing, you even mentioned it early on, when getting into this field, there's something that just sparks and it just gravitates attention to you, and all of a sudden you just get excited about it. Our guest previous to this, Jamal Wolford, did the same thing. He's now in this water space, didn't even think about the water space, but he is super excited about the water space now. Talks about it all the time, talks about, the different people and just the people that got him into it, and, the excitement that it brings. So a lot of fun in this industry. And that's why, obviously, we talked about this early on. That's why we're doing this. We want to bring the light to this industry and bring people into this industry to see the value of this industry, because the water was on during COVID and all these other things going on around the world. The water turned on every time, the water went down every time. So that's powerful.
Exactly. So knowledge transfer, fantastic with these tools. If you can show live on trending, you can mentor people a lot easier. It's just telling them exciting. So another very important thing, and I'm not sure how is it in North America, but wherever I go, we miss commissioning engineers. But there's a real lack of committed people. Okay, it's also about work hours. It can be long. If I go there, there's no time limit. If you go there and you have to fix a problem, you have only a few days, there's no time. You get committed, but it's a great experience, and then you can relax a bit after it. So not everybody wants to do that, but being so exciting, and we need to train the next generation 100%. And I would love to have these tools on my hands,
Absolutely.
As a follow-up on a visit, for instance, as a follow-up of the visit, it can, whatever they heard, they will implement, they will look at graphs themselves, and here you are.
The commissioning and startup side, I think when I was young and unmarried and didn't have kids, it was the part that I liked the best. It was challenging, but it was always an interesting adventure. I always learned a ton, and I loved doing it. As you were saying earlier, Jeorg, as you get a little older, that's the stuff that really is, it takes a toll on you. It's long, often entirely ad-libbed to the whatever the construction schedule and the commissioning schedule is, and things go wrong and schedules change, and you're under the pressure all the time. And I'm sort of glad that I'm not doing that in my career anymore, but I really enjoyed doing it for the few years that I got to do it, which segues me to the question I wanted to ask you, something a little more lighthearted. You've obviously been all over the world and have run a very interesting career, I think. Can you, without naming names or getting yourself into trouble or anything, any good stories, or what's your best adventure tied to a commissioning or troubleshooting or travel? Anything you could tell us?
Oh, it's every site, wherever you go, whether it's South America or Philippines, whatever. Even during COVID, when we did a remote plant, remote commissioning, where we just constructed out of cloud-based things a little bit of a monitoring. We had the local team, good engineers, and they did a Baptist sizing of the plant before they started, the startup. So they put a table with flowers, and it was a Buddhistic system. Fantastic, or the food, if I'm really lucky, one of the foremen or the even operator will grab me and show me a little restaurant around the corner. I don't need to go in the hotel for international food. I'd love to go out, and these things are really, really interesting things. Wherever and usually public holidays. Often these emergencies are just happening when there are some critical holidays, and they have a shortage anyway. So you see local celebrations in the evening, and you usually go out, and talk to the people. This is a fantastic approach. Technically it's challenging wherever you go. It's similar problems, but it's really the people that makes it so interesting.
I love that, Joerg, because I'm a foodie guy too. So, and that's one of my requests. Everyone's like, "Where do you want to go to dinner?" I'm like, anywhere where I haven't been, and it's not a chain.
Yes, exactly. These little, No, it's fantastic way to see the world without spending without spending your own money.
I completely agree, and the foodie aspect. I mean, some of the best Indian and Bengali food that I've ever had has been in like the canteens in Saudi Arabia at some of these sites. Some amazing food that you would otherwise I likely would never have been exposed to.
Yes.
Yeah, and eat what the locals eat what they do when in Rome, so to speak. It's always a fun part of it for me too.
Yeah, exactly, and you would be surprised. Yet my friend Abdullah, also in Saudi, took me to a little Egyptian restaurant because he was Egyptian, and we had a basic fish, but a special fish just in oil and with lemon, in a traditional thing where you sat on the floor, and it was the best fish I ever ate, and these things, and our deputy CEO in one of the big plants took me out to his camels, and I was able, because I milk my own cows, do a bit of cheese here with my family. And so he took me out to his camels. So we had some camel milk, which I never had a chance, fresh from the camel. So
wow,
a lot of or coffee. Yeah, coffee, because you're food lovers too. Coffee in a big Saudi Arabian plant for lunch. It's totally different how we see coffee nowadays, the Italian style. It's green, almost not roasted, very, very bitter, but served with a dried goat or camel milk biscuit, which is a kind of a sour milk biscuit, but it was all about quenching thirst. So it's not what you expect, and no milk, of course, but this is the tradition how coffee actually came from Ethiopia in these countries as a thirst quencher and valuable. So you would share it. So you learn.
And those are experiences that you'll remember forever because you got to do the local custom instead of, like you said, eating a club sandwich from the hotel lobby restaurant. Way more interesting to do what the locals are doing. And I agree with you. It's one of the benefits of this industry, especially the seawater desalination side, is I think a lot of folks like you and me, you're having the opportunity to travel to places that otherwise you probably wouldn't go or wouldn't think to go necessarily, and getting exposed to local customs and other people. Yes. And that's been a incredibly important part of my life as well. Interesting to hear you having the same experiences. I think
one good thing for young engineers too is Australian mines. With your friend and colleague and boss Hip coming from Australia, we spent a lot of times being sent out to the remotest place in Australia, because mining is often really exposed place, and you get the most amazing food in their cantina, because you only attract good people if you feed them well in such an arid environment, and you've got little wallaby kangaroos in front of the canteen hopping around, and some strange birds, and you hope you don't jump on a on a snake. When you go into your boots, you keep the boots. Everybody says, look, keep your boots inside. You don't want to keep your boots inside after a 12-hour shift, but keep your boots inside because there might be a snake in them next morning.
Understood.
Good stories. No, it's a wonderful industry.
It is. Yeah. That is awesome.
Absolutely. And shout out to Hipley Turing, CEO, who we do this podcast at his pleasure. And we very much appreciate him allowing us to do this. But Hip has certainly had an interesting career, an interesting life. Someday we'll interview him on here and get to hear about his background.
No, definitely.
That'll have to be a longer podcast.
Yeah, well, that might be a special 2-hour episode because Hip's got some things to talk about for sure.
Oh, yes. Yeah. And the industry is small, and this is also a funny thing, Years later, we worked together many years, and years later, we find out that on a project I was in Pakistan as a troubleshooter, and he actually was part of the design team as one of his first jobs.
Wow.
And everywhere where I go, you suddenly you find people. Our industry is not large, especially the desalination industry. Everybody knows everybody, so it's also really nice because you've always got people to fall back on, to ask, and again. It's a great thing for young engineers or young operators to join. Can't be any better. It's really camaraderie and networking, and nobody's holding back on information. And so I'm excited to see these things growing, that we finally also get some good data and not just PDFs, handwritten PDFs or Excel sheets, which is a bit better. CSV file is probably more painful than paper by now. Just from the SCADA.
It depends on the quality of the handwriting and the handwritten logbook. If it's good, then you're right. That's better than a CSV file. If it's bad, then I'd prefer the CSV file.
But then you have to be a Visual Basic programmer that you get your own thing right, because you cannot scan through all the data. So we're all looking forward to the next steps.
Absolutely.
Getting data recognition. Huh?
Well, Joerg,
we've been over an hour, so we really appreciate you joining us, being on the podcast today. It's been a fun conversation.
No, perfect. Thank you. When I saw your first episode, I knew exactly this would be a fun hour and exchanging a bit of old stories. I hope it's not too boring for the audience, the younger guys, just hearing us laughing and say what wonderful food we're having, because we leave all the stress part away and why we have not so much hair or gray hair or
right.
Right.
But there's good and bad in all of it. So, not every job's perfect. I've never heard of a perfect job. So
that's right.
But there's been a lot of goods. There's been a lot of relationships, a lot of camaraderie, like you said, met a lot of interesting people throughout the years, passionate people. That's one thing in this industry that, there are so many people that are passionate about what they do in this industry. That's what, is really fun for me as, when I first got into it is, talking to people, and the amount of time they spend learning this industry is a lot. So, and I can tell you've done the same thing. So it's exciting, like you said, it's exciting to teach the young people that are coming up and seeing them be that passionate as well.
Yeah. And the responsibility about it, it's a good thing. You said the water kept flowing during COVID.
Yep.
It's such a simple thing. Most people don't think about it, but it's true, We're all part of this value chain to make the water flowing, and water is food, water is agriculture, water is everything, so you can feel good about it, even if it's like technically, and often you have to clean water you shouldn't have polluted in the first place, but you still do the right thing, you have to clean, and we are moving also towards alternative energy sources. It's very surprising, especially in the Middle East, where a lot of people think, it's all about oil and gas. No way. We see photovoltaic. We see a lot of trends going to fully autark, or at least partly. And then it gets even more interesting, from an environmental point of view. It's no longer these energy-hungry big desalination plants taking 7 kilowatt per cubic meter, but we are down to under 3 and from photovoltaic. So this is a sustainable industry too, pretty soon.
Yeah,
that's
absolutely.
The hope. Yep. Well, all right, Joerg, thank you very much. I think this was, I don't think this will be seen as boring. I think this is great because it's a very different perspective on what works and what doesn't work from a day-to-day operation standpoint, which that's exactly what we wanted to create a forum for with this podcast, people to come on and tell their different stories, their different points of view on what works and what doesn't. So thank you for being here with us today. Go check out Jeorg on LinkedIn, especially if you're in New Zealand. And thank you all for listening. This has been the Fluid Operations Podcast with Miller Truby and Kirk Wessel, and we will sign off and see you next time.
Thank you very much. Yeah, keep it up.
Bye, everybody.
Guys, bye-bye.
See you next time.